Welcome to Drone System and Control course. Lecture 7A talks about MATLAB demonstration on UAV sensors. In the lecture we discussed about different UAV sensors available. One to measure the states of the system, right? So we have IMU, we have GPS, then you have a barometer, or you can use single point LiDAR on radar to get your height measurements. Then you have other sensors which look at the context in which the UAV is flying. You could use 2D LiDAR, 3D LiDAR or 4D radar or even a camera to understand where is the obstacle, how far is the obstacle from the drone, what is the relative position, relative velocity, all this can be estimated. Now if you are looking at simulating these sensors, right, we need to understand how you can add the sensor in the simulation world. We also talked about how we can create the model, right, the mathematical model, and how we can simulate the drone in MATLAB, the 6 degree of freedom model we talked about. Now it is very important, how do we add the sensors to these model and how do we use these sensors and add practical noises to these sensors, and so that the model what you have is as close as possible to the real world. Once you have the model is closer to the real world, it is easier for us to generate or design a controller, validate the controller, design the navigation system, validate the navigation system how good it is with respect to the real world effect, and we can implement them in our actual hardware. Okay. So in this lecture we are going to talk about two sensors. I am going to talk about how IMU can be added in MATLAB and how to add radar sensors to it. Okay. So now let us look at how do we simulate IMU sensor which is mounted on UAV, right. You can create an adapter for IM sensor from navigation toolbox and you can get the readings from there, right. So how do you create a sensor adapter? You have to use a command called create custom sensor template, right. Then you can use the particular file called UAV IMU and you can edit them, right, and you can add the respective noise based on the sensor sheet. You can add the noise so that it will reflect as close as possible to the actual IMU sensor. Now I am talking about how to set the sensor adapter in UAV scenario simulation. You need to talk about scenario, which is talking about UAV scenario dot, that is a function fly. You need to talk about start time, when do you want stop time, and update rate, what is the rate at which this need to be updated. Once you create the scenario, you can plot how the trajectory is going to be. You can define the waypoint from where and to where you want to go, and you can talk about time of arrival. All these information you can just provide so that the sensor simulates this information, right. Then you can call a UAV sensor IMU, right, UAV IMU IM sensor, that is a scenario what we have created. Automatically it adds respective visualizations of the scenario. You can plot those scenarios, right, and it will show how 3D scenario gets evolved over a period of time, right. Let me run the file to show you the effect of those graphs. Okay. So here I am trying to plot, that is my scenario. I am talking about the red arrow indicates my heading is what you see is a east and north, right. I can plot the sensors, I can visualize the scenario in my own world, and let me play how it varies. I can change the speed at which it is moving here so that you get to know. So that is how the drone is navigating. Okay, I am playing it at the lowest possible speed one more time to get an understanding. I started from north, I am moving and move ahead. So I can simulate how this UAV is moving and how I can get this sensor and I can plot the scenario and understand, right. I can look at the conditions, how the accelerometer, 3 axis, right. What are the values of the accelerometers and every time instance. I can simulate the angular rates, right, the gyro measurements. I can show you how the accelerometer works, sensor reading we are getting in x, y and z axis, right. How the angular rates are there in phi, theta, psi, we get those data here nicely, right. So, we can model the sensor in MATLAB and we can add the realistic noise informations and we can simulate them and that data will be available. We can integrate this very nicely with respect to our 6 degree of freedom model. When we go about scenario generation lecture, I will show you how full 6 degree of freedom model along with sensors integrated into the visualization scenario, and we can create specific situations where we can have external sensors giving measurements too, right. Now, let us look at radar sensor, how we can mount the radar sensor. Okay. We can simulate the radar sensor also in UAV. We can create a typical UAV scenario. We can create a custom radar sensor, right. We can talk about how to set up the UAV scenario, same like previous time when we talk about IMU, we are talking about stop time, how long we wanted to run and what is the history buffer size you want, right. Then you can talk about what is a platform, which is a UAV platform, right. What is the trajectory, what is the wave point it is going to take, time of arrival and all these informations are mentioned. Then you can create a UAV platform and look at here I am again talking about how the sensors present with respect to the UAV scenario I am talking about here, right. I am trying to visualize the radar detections that what we can get, right. When you are talking about it, I will probably play at a very slow speed so that you get an idea about it, right. This is my measurements when I am getting for the radar, right. I can look at various time instance, how it is moving, what is that information I am getting, right. So, we can model the sensor, we can add the scenarios and integrate the sensors in MATLAB, which emulates as close as possible to real world scenario. Once we have a 6 degree of freedom model, once we create scenarios, like for example, if you are looking at obstacle avoidance, you need to create a scenario where obstacles could be present. Then we understand the control, we talk about speed control or attitude control system, or if you are talking about precision landing, we need to talk about height control system. Once we have this and navigation lecture is done, we will look at how we can integrate all of this to simulate the complete system, and we look at the real world data and what we measure in a simulated world. So, what will happen is once we get the completely integrated system, we will be able to validate the controller design what we have done or the autonomy algorithm what we have done for obstacle avoidance. We can validate it and that can be integrated. This will reduce the fine tuning required in real world environment, because there are a lot of uncertainty present in here. If we can model those uncertainties directly, we can reduce the time required to tune the algorithms for practical demonstration. Thank you.